Can everyone hear my voice and see my screen?
Yep.
Yes.
Cool, thank you. So this is obviously the first recitation. Feel free to chime in and ask any questions as they arise. My basic plan is to, primarily to answer questions that you guys have regarding the homeworks. I'm planning on posting these on a YouTube channel, the recitation recordings on a YouTube channel that the link is on the website or the Blackboard page. I may also either post answers on the YouTube channel or reference these homeworks. So, whoopsies. So if you were to normally take this course when everything's in person, we don't normally have web work. Instead, we have quizzes, and this is replacing the quizzes, and also kind of the homeworks of these are also a good thing for you guys to go over, but they aren't enforced. So if you want extra help or extra questions with answers and sometimes with detailed solutions, you can just search Drexel Math 200 homeworks, and then it'll bring you to this page, and I'll do it by topic. And you have the option of either doing the answers, or you can look at it with or without the answers. And the answers are particularly useful for things that are more visually oriented, because I don't know about you guys, but if I were to draw this, it would not look nearly as nice as this does, or any of these really. So does anyone have any questions on that? Cool. So I looked at the statistics and the three problems that people, or the three questions that people seem to have the most problems with on this first homework, web work, were problems 3, 5, and 6. So I was planning on just walking through 3, 5, and 6. And if anyone has any other questions that they want me to go over, you can either ask me to do it now and I can do it now, or you can ask me after I finish these three problems. Cool. So if I'm doing addition of vectors, it's just point-wise, or it's a component-wise addition. So if I add u and v, I just take the first components of u and v, and then I get 1 plus -5, so that's -4. The second components, so that's -2 plus -5, that's -7. And then 0 plus 1, the third components is just 1. And it's going to be the same thing with component-wise subtraction here. You can also think of this as u plus -v, and then you can just do it as distribution, as if you had distributed, but I'll do it as subtraction component-wise. So we get 1 minus -5, that's going to be +6. We get -2 minus -5, that's +3. And we get 0 minus 1, so it's going to be -1. And you can go about and do the whole thing again, just in the opposite direction, -5 minus 1, -5 minus -2, and 1 minus 0. And you'll get the same thing. But what I'm just going to do is I'm going to say this guy is equal to the negative of this. So it's going to be equal to the negative of this. So just going to be -6, -3, +1. Does anyone have any questions about those first three? No? Cool. So what am I going to do for, I guess, D here? 3 times U?
You just multiply each value of u by 3.
Exactly. So you just multiply component-wise and you get that guy right there, 3, -6, 0. What about for the next one?
multiply each value of v by -1/5.
Exactly. So that's not it. So if we multiply by -1/5, then we get -1/5 times -5 is +1. Same deal for the second component. And then we get -1/5 for the third component. This last one is not anything new conceptually, but so we have 8u minus 2v. You just have to stack some steps from the previous sections. So let's do that. We'll do 8 times u is going to be 8 times eight -16 is 0. And then I'm just going to change this to a plus and distribute the negative inside. It's the same thing, but so now I have +10, +10, -2. When I add these two guys together, I get 18, -6, -2. And that goes right there. Does this make sense to everyone? Does anyone have any problems with any of these? Also, yell at me if I make computational mistakes. I will at some point. Cool. So how am I going to calculate the vector from my first point to my second point? So if this is P1, this is P2, how do I calculate that?
Do you just find the distance between the two?
Yeah, exactly. Or I do it component wise, right? Because the distance is just going to be a single number, and that's actually going to be the length of v. But I do like the x distance and the y distance and the z, or the movement, I suppose, more than the distance, because it can be a negative number. Distance can't be negative. So I do 7 minus 2, right? That guy. And I do P2 minus P1. And then I do the same thing again here. 8 minus 3 and -4 minus -1. So that gives me 5, 5, -3, right? So that's my vector. What is the length of this vector?
It's the if you square all of them and add them together and then square that number.
Square root that number.
Square root that number, sorry.
Yeah, no worries. And that's also if you were to do the distance formula on these guys, right? Because the distance formula would be, so if this is x2, y2, z2, this is x1, y1, z1, then the distance formula between them would say, okay, we want x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, and then square root that whole thing. But guess what? We already calculated these guys, right? They're 5, 5, and -3. So what we're doing here is the square root of 5 squared plus 5 squared plus -3 squared. So that gives me the square root of 59. So my length here is the square root of 59. Does that make sense to people?
So did you combine the 5 squared, the 8 squared, and the -3 squared together, and then you move the squared out, or?
No, so there was no 8 squared, right? Because it was 8 minus 3 squared, so that's another 5. And then the square root
okay.
all 3 of these squareds, and they're not the same thing. They're not the same thing that I'm squaring, so I can't just pull out the square root. I have to do the computation inside. And then this guy is 25, this is 25, this is 9, so 25 plus 25 plus 9 is 59.
Okay, thank you for clarifying. I got confused for a second. Thanks.
Cool. So if the tail of V is at this point, how am I going to calculate the tip?
You just add V or add V's components to that that point.
Exactly. That's exactly right. So this is my point, or this is my my initial point, my tail point. This is my vector. This is my tip. I just add the tip to the tail, and then I would get, so I would get 5 plus 5 is going to be 10, right? So this plus V. So it's going to be 10. 5 plus -3 is going to be 2. And then 2 plus -3 is going to be -1, right? So now if I do, what about this next one? So if the tip is at this point, how do I get the tail?
You just subtract.
Exactly. I'm just going in the opposite direction now to get to the tail. So I do this guy minus V. So 3 minus 5 is going to give me -2. 5 minus 5, or sorry, -5 minus 5 is going to give me -10. And then 3 minus 3 is going to give me 0. So this right here is my new point. What is a vector that has the same length as V but points in the opposite direction? We're going to calculate that.
Would you just multiply it by -1?
Exactly. It's just -1 times V. And then if I just distribute that, I get -5, -5, +3. The next one, same direction as V, but twice as long.
I also think 4 should be 6 at the end,
Uh,
minus the negative.
yes, thank you. You are correct. Like I said, I'm bound to make computational mistakes at some point. Thank you. So this guy, we want the same direction, but twice the length. So what's that going to be? Yeah, just multiply by 2. Thank you, Shamar. So we have 2 times V. So that's going to be 10, 10, -6. Cool. Does this make sense to everyone? Awesome. Okay, so what about this guy? Can someone tell me a unit vector that points in the same direction as 1, 0?
That is a unit vector, isn't it?
Yep, it is. It is just 1, 0. The unit vector that points in the same direction as this unit vector is itself. Thank you. About the unit vector that points in the opposite direction of this guy.
Are there multiple unit vectors that would point in the same direction as 1, 0?
No,
That was only 1, 0.
there's only ever going to be one unit vector that points in a given direction. Unless you want to say like the negative points in the opposite direction, but sometimes you would call that the same, but usually we wouldn't.
Okay, thank you.
No problem. So if I call this vector V, right, how am I going to get the unit vector that points in the opposite direction?
Just multiply by -1, right?
That'll get me something faces in the opposite direction, but it won't be a unit vector yet, right? So if we want to get the unit vector, what we do is we just do V divided by the length of V, or the norm of V. They mean the same thing. I think you guys normally call them length for my purposes, I normally have to call them norms. They're the same thing. I'll probably end up calling them norms a lot. Sorry. So what, and then I want something that points in the opposite direction. So I'm just going to do negative, right? So how do I find the length of V? We already did this before. Someone shouted at me.
Square root. And
Yeah.
it's like 3i squared, 2 squared, and plus 3 squared.
Yeah. Exactly. So we're just doing the square of each of these components, right? Or the square root of the sum of the squares. So then we get square root of 9 plus 4 plus 9 is equal to the square root of 22. So what I get here is when I distribute that negative and divide by that root 22, I get negative 3 divided by root 22, comma, because of that negative, this switches to positive, so I get 2 divided by root 22, and then positive again, 3 divided by root 22. Does that make sense? Cool. So what about the unit vector that has the same direction as the vector from the point A to the point B? So first off, how do I find the vector from the point A to the point B?
Subtract A from B.
Yeah. And actually that'll be a good name for this vector. So that'll be 5 minus 0, comma, -1 minus -5. So that's going to be equal to 5, comma 4. But I now want to make it a unit vector. So what I want is this guy divided by its norm, or divided by its length, its magnitude. So that's going to be 5, 4 divided by the square root of 5 squared plus 4 squared. So that's equal to 5, 4 divided by the square root of 41. Right, 25 plus 16, square root of that. So that is 5 divided by 41, or by the square root of 41, comma 4 divided by the square root of 41. Does that make sense, everyone?
Yeah. The question that I had about the first one, if it wasn't a unit vector, if it was just like a vector that points in the same direction, would there be multiple answers?
Yeah, if it just says give me like a different vector that points in the same
It
direction,
would
there's
just be any parallel vector.
yeah, it's infinitely many. Assuming that it means same direction, as in like not the negative of it, you just multiply it by any positive number.
Okay, yeah, that's what I thought. I didn't look at the unit.
Yeah.
Okay, thank you.
Cool, no problem.
I entered, you said for part 1 of the first question, it says the unit vector in the same direction as 1, 0 is vector 1, 0. I entered the same thing as my question and it says it's incorrect. So I don't know what I did wrong.
Is your question the same exact one, or is it a variant?
No, it's -1, -2, but I entered vector -1, -2.
So the problem is that one is not a unit vector. So -1, -2, the norm of this guy is not equal to 1. So
Okay.
what I have here is if this guy is equal to V,
Mhm.
then its norm is, or its length is also 1. So I'm doing V divided by the length of V, and that's just V divided by 1 is just V, right?
hmm
So for this guy, I just have to check out what is the length of it, and that's going to be the square root of 1 squared plus 2 squared. So that's going to be equal to the square root of 5, and I'll have I'll get -1 divided by root 5, comma -2 divided by root 5. Does that make
Oh, okay. Thank you.
cool? Do people have other questions, either on the ones that we just covered or other questions more generally? Cool. In that case, you are free to go. I'll stick around if anyone else wants to ask questions with a smaller audience.
Thank
All
you.
right, thank you. Take care.
Thank you. Thank you.
Thank you.
Yeah, I just had one quick question about
Sorry.
like how, I don't know, it's been a while, but I don't know like the quick way to do like square roots inside the web work.
Oh, let me see.
Like I forget what it was, but
So I think you can just do SQRT of something, right? Is that correct? You can just do SQRT of
is that what it is?
Okay. Sorry, Andrew, did you have a specific thing that you want me to rewrite? Because now the stuff is cleared.
Yeah, I was actually, I had to go grab something. My dog could grab something, so I missed that last part.
Okay.
But yeah, sorry about that.
No worries. So this is actually recorded. I should probably stop recording. Sorry.
Okay, cool.
And I'll just post it on